So let's look at the derivative of a function. This is how we define that. Right, this is one way to define the derivative. Now, a is some number. So this one is the derivative of the function at a. And you can do this for many a values, right? You can try this at a equals 1, a equals 2.7, 8.9, and so on. So you can do this for many possible a values. Now, if you just say, I want to write the function to be like this, basically you relabel this function, right? You just relabel a to be x. And here, x is a symbol for all possible values of a, not just a single one, but many of these. And if you do that, you can see you actually have a function, right? Because you have this input x. So this one means you can calculate the derivative at any x value you want. Not just a single point, but any value you want. Okay. Now, if you look at this function below, you have this curve. This is fx, the function. And you can do the derivative, right, at any point you want. You can do this here or anywhere, right? And we know that the derivative is the slope of the tangent line. So for example, if you do the derivative at this point, this a, right, you need to draw the tangent line, which is the line that's basically the steepness, the slope of the curve at this point. And this, you can see that the slope is negative, right? So you know f prime at a must be negative because this tangent line is decreasing. Now, if you choose another point, say this one, you draw the tangent line, which should be like this, and it's positive because the tangent line has this upward trend. So the derivative is positive at this point. Now, at some other point, say here, okay, so that's like 2.1 or something. If you make the tangent line, it's actually flat. So you can see that the derivative actually tells us the direction of the movement, right? If the movement is going upward, the derivative is positive. If it's kind of a constant, the derivative is 0. If the curve tends to go downwards, the derivative is negative. Okay, and you can draw these tangent lines at any point you want. Just keep drawing this. This is one, another one, and here's another one, and so on. Okay, now you can see the pattern. Okay, up to this point, this point has some tangent line that's kind of flat, right? So that's like, at this point, the derivative is 0 because the tangent line is horizontal. So from here all the way to here, right, for all points within this interval, the curve goes downward, right? It goes like, like this. So it goes downward. That means the derivative is negative in this range. And then after this point, you can see the curve is climbing up. So from here to this point, the derivative is positive because you are moving higher and higher. Okay, and at that point, this 2.1, the derivative becomes 0 again, and then it go back down. So after 2.1, the derivative is negative again. Right? You can see this moving. There are three regions basically. In the first part, from like very negative up to, let's say this is 0.5. Okay, up to 0.5, you have this downward trend. So the derivative is negative. Between 0.5 and 2.1, you have upward trend, and the derivative is positive. Then after 2.1, the derivative becomes negative again. So it goes down, down, and up, and back down, right? So you should have some idea about the values of the derivative at any point. Just look at the slope of the tangent line. Now, if you do this very carefully for all points, you will have something like that. Okay, so here, originally from here to here, let me use black color, from here to here, right, as I just mentioned, the derivative is negative. So that's why so here on the top you have fx. Okay, the bottom one is actually derivative of x, so f prime x. So from like a to b, the derivative is negative. So that's why these are negative, right? You have, so this curve is below the horizontal axis, so it's negative because the original function tends to have this downward trend. And then it moves up, right? Starting from B to all the way to D. So from here to here, it moved up. That means you have positive derivative. So that's why you have this range, this curve. Okay, everything is above the horizontal axis, so it's positive. The derivative is positive. But still, even though they are all positive, they have different values. Okay? So that's why we call the derivative, some people call that rate of change. Okay? So that's also another name for derivative. It's how fast the function changes. If the rate of change is large, that means the function is changing very fast. So that means it's very steep. If you look at the function, is very steep. So it's going to be something like, if the rate of change is large, that means you have a very fast increase. So it's going to be something like that. If you look at the function, it goes very fast. So this is very positive rate of change or very positive derivative. It could also be negative. That means you have a very fast decreasing. Okay? Either way, either a very big positive number or a very big negative number, like that. So this is very positive value. This is very negative value. But both have very big rate of change. Okay. Now, if you have a very small rate of change, that means even though the function is still changing, it's very slow. So it's going to be a very flat one. Like, you have an increasing, but it's very slow, right? Just increase very slowly. That's called a very low rate of change or very low derivative, very small derivative. Okay. Or it could be a decreasing trend, but very slow decreasing trend. Okay. So the value of the derivative depends on how fast the function changes. If the change is very fast, the derivative is large. If the change is very slow, the derivative is very small. So here, if you look at the range between B and D, okay, right after B, this little range, right, the change is very slow. You just get a very slow increase. Like, it's almost flat, just increase a little bit. So that's why the derivative is positive, but not very big. So that's like you have very small positive values. Now, as you move toward C, the slope becomes higher, right? It's pretty fast change. It's very steep. So the derivative becomes large. That's why the derivative at C is kind of high. Okay. Then after C, it's still increasing. So you still have a positive derivative, but it becomes slower and slower, right? If you follow the line, it goes like this. So it becomes slower and slower. Even though it's still increasing, but not that fast. So that's why you get this part. The derivative is still positive, but the value becomes lower. Right? So you can just keep doing that. Right after D, this part, it's almost flat, right? But it's still going downward. So that means the derivative is negative, but not very negative. It's pretty close to zero. So that's why you have this region. And you can keep doing that, all right? So the top one is a function. The bottom one is the derivative of the function. Just by looking at the function, you can get the idea about how the derivative will change.